All right, so the last section we're going to be doing is 9.4, solving trig equations. All right, I would highly suggest having your unit circles, so that's 8.3 out, or you can just Google it. Also during this, if you have written down all of your trig identities, so for example, the ones that have like this on there, and then the difference and sum, and then the half angles, I would grab out that sheet so you have that handy too, okay? All right, so for example 1 says solve trig equations with infinitely many solutions. Find all the solutions of 3 tangent equaling tangent plus 2. So we're just gonna kind of view this as if this was an x. So first thing we would wanna do is combine those together. Sorry, I didn't mean to move that so much. So I have 3 tangent theta equaling tangent theta plus 2. So first thing I'm going to do is I want to move the tangents so they are together because they are like terms. So how I'm going to do that, I'm going to subtract the tangent theta. We're going to subtract the tangent theta. Okay, so 3 minus this is 1 would give me 2 tangent theta equaling, and then we have this 2 because those are going to cancel. Okay, well, the 2 and the tangent are being multiplied. To get this tangent by itself, I'm going to divide by 2. So those cancel, and then I divide by 2. So then that means I have tangent theta equaling 2 divided by 2 is 1. Okay, so then what we're going to do is we are going to look to see where tangent theta equals 1. If you remember, I don't even remember what section it is, but when we talked about tangent and sine, we looked at these 2 quadrants, and when we looked at cosine, we looked at these 2 quadrants, okay? So tangent equaling 1 is going to be at either pi over 4 or 45. Doesn't matter which one you use, doesn't specifically say. So we're just gonna use radians because I know next year you will be using a lot of radians. Okay, so I know theta is going to equal pi over 4 because that is where tangent is 1. Tangent is -1 here, so that's why we're not going to do this one. Okay, because it says many infinitely solutions or infinite solutions, that means I'm going to go around that unit circle multiple times. So how we're going to indicate that is we're going to be adding 2 pi and then n, which n represents that number of times you're going around the unit circle, or the number of rotations. And then that would be my final answer. Okay, so see if you guys can do B and then check your answers. Okay, so for B, I have 2 cosine theta plus the square root of 3 equaling 0. Okay, we're just gonna treat this like this is an x. If it makes it easier to make it into an x, you can do that and then change it into the cosine after. So first thing I'm going to do is subtract the root 3. Subtract the root 3. So I would have 2 cosine theta equaling negative root 3. Okay. To get the cosine by itself, I'm going to divide by 2. Divide by 2. So then I'm going to have cosine theta is going to equal negative root 3 over 2. Okay, so we're going to look on our unit circle. So remember, cosine is dealing with the first quadrant and the second quadrant. I look for cosine, so that's going to be my first number, first value. I have negative root 3 over 2, which my radians is that, or my theta is 5 pi over 6. So theta is going to equal 5 pi over 6. To represent many solutions, we're going to add that 2 pi n. Okay, and that's going to be that answer. All right, so for example 2, it says solving trig equations in quadratic form. Okay, so what it means by quadratic form is I do have this squared now. Okay, so solve each equation for the given domain. So my domain is going to be from 0 to 2 pi. Okay. So that means I'm just not going around the unit circle multiple times. I'm only going to be doing the one time. All right, first thing I'm going to do is I want this to equal 0, or I'm going to use kind of substitution. I'm going to say x equals sine, okay, theta. You don't have to do this step. I do think it's going to help some of you guys visualize this a little better, so that's why I'm going to do it that way. So I'm going to have then x squared minus 2x equals 3. Okay, and then we are just going to be solving for x, which you guys should hopefully know how to do. I'm going to subtract 3. So I'd have x squared minus 2x minus 3 equals 0. And then we're going to factor. So I would have multiplying to -3 and adding to -2. That would be -3 and 1. So then I'd have x minus 3, x plus 1 equaling 0. Okay? So then from here, I personally like to then substitute that sign back in. So I know x equals sine, so this is sine theta minus 3. And then I have another x, this would be sine theta plus 1, and then equals 0. Same idea, if I have two factors that equal 0, I'm going to set both of them equal to 0. So I'm going to have sine theta minus 3 equaling 0, and then sine theta plus 1 equaling 0. Okay. From here then I'm going to add 3 to both sides. So I'm going to have sine theta equaling 3. On this one I'm going to have sine theta equaling -1. Okay. With this, sine theta equaling 3, just a reminder that our domain is from, or our range is from 0 to 1, so we can't have it being 3, so this is going to be a no solution. Okay. Then on this one, where sine equals a -1. Sine equaling -1, so we know it's cosine sine, so that wouldn't work. Well, here I do have sine equaling a -1, so that is going to be my radian, or my theta is going to be 3 pi over 2. So I know theta is going to equal 3 pi over 2. Okay. Alright, what I want you to do, we're actually going to skip B, but I do want you to try out C and then see if you get that same answer that I do. Okay, so for C, once again, you can make this into x equaling cosine. So I would have x squared plus 2x, and then I'm just going to subtract the 3 over equaling 0. Okay, so I'm multiplying to -3 and adding to 2. This would be a +3 and a -1. So I would have x plus 3, x minus 1 equaling 0. I'm now going to substitute that cosine back in. So I have cosine theta plus 3, and then cosine theta minus 1. Okay, so cosine theta plus 3 equals 0, and then cosine theta minus 1 equals 0. Here I'd have cosine theta equaling -3, which it is outside of our limit, so this is going to be no solution. This one I'm going to add 1, so cosine theta equals 1. Looking at the unit circle, cosine is going to be my first number, which cosine is right here equaling 1. So that means my radiance is going to be, or sorry, my theta is going to be 0. I keep saying radiance. It's going to be 0. So then that would be my final answer. Okay, we're going to do the last 4 problems tomorrow. You can start working on that homework for tonight though.